Here's the graph of f of x, and now we have things combined. So I'm going to color code this. This 4 is outside the function. That's going to be a vertical stretch. Use that abbreviation. And that's going to mean that you are going to multiply your y values by 4. Then this negative 0.5. That is going to be a horizontal reflection and a horizontal stretch. Because x's are lives. You are going to multiply your x values by negative, and that fraction's a half, so the reciprocal would be 2 over 1. We'll multiply our x values by negative 2. The only thing the x's don't lie about is when there's a negative. They're still negative, which kind of also makes sense in our sort of theme that we're working up. So the only thing they're truthful about is when they're negative. Other than that, everything gets messed up a little bit. So especially when you start to do multiple things, it really starts to be nice to take a couple of points and see where they go. So, not 0, 0. This is the most important point, because that's where this graph starts. So I'm definitely going to do that point, and I'm going to look what's going to happen to it, and above it, I'm going to say, well, I'm going to multiply my x values by negative 2 and my y values by 4. Okay? Definitely going to do that point. And then I would probably, let's see what other nice, this point here, negative 1, comma 1. Have any other nice points? Yeah, 2, comma 2. So I take 2 or 3 points from my original one, and I look at where they end up. And I'll also tell you at this point, the next step, the mental math is easy. So easy that sometimes you don't pay attention and start thinking what you're going to do next. And that is the easiest place to make a silly mistake. So take your time and pay attention to little details. I want to multiply my x values by negative 2. Those are my x values of the first ones. So I might even do all of those first together. This is going to be 4. This is going to be positive 2. This is going to be negative 4. Then I'm going to multiply my y values by 4. This will still be 0. This one will be 4. And this one will be 8. I go to my graph and I put these dots on there. I know I'm going to have 4 comma 0, 2 comma 4. Oh my goodness. Negative 4 comma 8 would be like, that's off the graph over there. Now I've got 3 points. This still can be somewhat confusing as what this graph is going to look like in the end. Okay, a couple of things that can be really helpful. This was a very important point, right? Where did that point end up? It ended up here. So I know my starting point, I'll put my pen on there, is there. I'll put my arrowhead on the end the other way. Other things to check, okay? You can check, does it look like we stretched it vertically? Does it look like we flipped it horizontally? Does it look like sometimes the stretches are hard to see in the end. Does it look like we might have also stretched it horizontally? Okay. See the red curve shape? Is our black one have that same shape? You're going to lose marks if you just connect the dots, straight line. Then you've changed the shape of your graph. The exam will be like, don't like that. The original shape was sort of a curve. Our shape needs to have that similar kind of curve as well. Okay, this time I reread the question. I reread it in my head. Sometimes I do that, just look at the question and reread it. I have to do domain and range of each. domain is the original x values are bigger than or equal to -2. My original range is my y values were bigger than or equal to 0. On my new function in black, my x values are now less than or equal to +4, and my range is still bigger than or equal to 0. Does anybody know what the original red graph actual explicit equation would be? So I wanted, because this is in function notation. They started off, the red graph is f of x. Does anybody recognize what the original red graph was?
Y equals the square root of x plus 2.
Y equals the square root of x plus 2. Now we can write y equals, or because it was f of x, I could write f of x equals square root of x plus 2. And what I'm going to do next is practice with you converting between function notation and explicit notation. So in our question, the black graph was y equals 4f of -0.5x, right? That's, scroll up, just make sure I didn't write any, yes. And the question is, are we good enough with function notation that we could change this into explicit notation? Okay? What do each of these things mean? Well, the 4 means you're going to multiply something by 4. So I can start by writing, this is going to be 4 times something. This f of -0.5x. Let's review function notation. If this is f of x, can someone tell me what f of 5 is? What do? We took our x, replaced it with a 5. Can you see that you would then replace that x with 5, and you would get the square root of 7. And we're really, really good with numbers. Function notation with numbers, students are amazing. Function notation with variables and letters, all of a sudden we get stuck. Okay? If you think what we do with numbers, right? F of 5, you just replace the x with 5. That's the basic rule of any function. Whatever you plug in replaces the x. So now I have f of -0.5x. It's going to replace wherever you had an x, now is going to get replaced with this. Just like I replaced when 5, I replaced with 5. Now I have a big square root, but instead of the x, and I'll even put it in bracket, I replace that x with this, and I would still have plus 2. Now some of these brackets aren't necessarily, I could simplify this, I don't need that bracket, I wouldn't need that bracket. I could write it like this. This is the actual equation of the black graph we did as an explicit equation. We're going to get really good at graphing these in sections 3.4 and 3.5 when we get there. But it's good to practice being able to switch from one to the other. One notation, function notation, and explicit notation. Okay, you can circle questions 7, 9, and 10.